Now we'll continue our steps in figuring out the F statistic and how to analyze the situation using it. We'll continue with the steps. We did step 1 where we defined the hypotheses. Now step 2 is to collect data and check conditions for the probability model, the ANOVA F test, as we described before. The conditions that allow us to use the ANOVA F test are similar to the two conditions for the use of the t-test, with addition of a new third condition. It's safe to use the ANOVA procedure when the following conditions hold. First, samples are randomly selected from each population and are independent. Secondly, the response variable varies normally within each of these populations. If we cannot verify the shape of the distribution of the response variable in the population, then we can still use the ANOVA test if the following situations apply. First, if the sample size is larger than 30, like we've seen before, we can use the ANOVA regardless of the shape of the variable's distribution in the populations. So similar to what we've seen before with just 2 mu's or means instead of more than 2. Secondly, if the samples are small, or less than 30, for example, the sample sizes, examine the distribution of the variables in each group. If the distribution of the data in each sample is not heavily skewed, this suggests that the variable may be normally distributed in the associated population, and we use the ANOVA test. This is the new condition. The populations all have the same standard deviation. That's our new condition. We haven't seen that yet when there's only 1 mu or 2 mu's, but now when there are more than 2, we need the populations to all have the same standard deviation in order to apply the ANOVA test. We will often have difficulty verifying that the population standard deviations are the same. Therefore, we check this condition by examining the sample standard deviations to see if they are approximately equal. They don't have to be exactly equal, but if they seem close enough, then we're doing pretty good. A common rule of thumb is to check whether the ratio between the largest sample standard deviation and the smallest is less than 2. If that's the case, we check off this condition that it's satisfied. Now we'll look at an example below. We'll test the conditions that are to see if we can use the ANOVA F test in a specific example here. With the frustration data for 4 majors from scenario 2 on a previous page, we use StatCrunch to calculate the summary statistics so that we can check conditions for use of the ANOVA F test. Here below are the summary statistics from StatCrunch. So we have in the first column your major, in the second column and the sample size, which was the same. It was always 35. And we saw the mean before. The business majors had a mean frustration level of 7.31, English 11.77, math 13.2, and psychology 14.03. Their standard deviations are, in the same order, business 2.9, English 2.09, math 2.15, psychology 3.08. In our sample, all the conditions are satisfied. First, all the samples were chosen randomly. Okay, we say check to that. Secondly, the sample sizes are large enough, n equals 35. And remember, our cutoff point is 30. That's larger than 30, so we're safe. We don't have to worry about the shape of the distribution. We don't have to check if it's normal. It's fine. The sample size is large enough. Thirdly, the new qualification. In order to use the rule of thumb, we need to get the sample standard deviation of our samples. The rule of thumb is satisfied because the ratio of the largest sample standard deviation to the smallest is less than 2. You just take the largest standard deviation, largest with 3.08, and divide it by the smallest. Between those 4, the smallest is the one from English, 2.09. Let's see, if we divide those, what do we get? When you divide those, you get about 1.47, which is less than 2. So we're safe. We should be able to use the ANOVA F test.